Thanks again, everyone, for joining us here today for our tech talk on what's new with serverless at AWS. My name is Chris Munns. I am currently a principal developer advocate for serverless at AWS. I've been here at AWS now for a little over 6.5 years across a number of different roles based in our New York City office. And for the last just about 2 years, I've been very much focused on this space of serverless and serverless technologies. So what we're going to cover here today? Well, we just a couple of weeks ago had our yearly annual developer customer conference called AWS reInvent in Las Vegas, Nevada here in the United States. There were a ton of announcements. There's really a lot going on in the serverless space. And so a big point of today's webinar is to help catch you up on where we are with a number of our serverless technologies. And there were over 100 announcements at reInvent. It was a really busy week. And for the serverless space, we had some really exciting things too. And so we're going to cut through today here, probably the most important in this space, and talk about how these features and capabilities can be used by you right now today. Now, for serverless, this is kind of a buzzword in the industry. It can mean a lot of things to a lot of people. But for us here at AWS, it really comes down to certain key criteria. And when we talk about serverless products, they are products that typically have to meet these four kind of pillars of capability, maybe as you might want to call them. The first is that there's no servers to provision or manage. This means no physical, no virtual, no container orchestration management that you should have to do when you're building a serverless-based application or architecture. Should automatically scale with usage. So as requests come in, we're automatically going to scale whatever compute or storage resources we need to behind the scenes to handle that workload that you're sending. Never having to pay for idle. This is a really key differentiator from serverless and other technologies in that you don't have to think about capacity planning in the same way that you would in a more physical world. And so with the aspect of never paying for idle, it really changes the dynamicness of only paying for exactly what your application needs when it's in use. And then lastly, availability and fault tolerance built in. Here at AWS, we have a concept called regions. We've got, I believe now, almost 20 of those globally today. Inside of those regions, there's another concept called availability zones. You think of availability zones as separate data centers that exist inside of this geographical bound area that is a region. And these availability zones exist inside of this region to help provide availability and fault tolerance for our services. Now, if you're building in a physical or virtual sense, you would have to think about that yourself. But with serverless, this is going to be built in, and so it's one less thing that you have to think about. So now these are technical aspects to think of for serverless. But what does serverless mean for your business, for your development or IT organization? What we end up hearing from customers is a number of what I would consider to be kind of intangible benefits. Things like greater agility, less overhead, better focus, the ability to handle increased scale of workloads, greater flexibility of the platform that we have versus maybe what they might be using previously, and then faster time to market. And now all of these are benefits that you only realize once you start using the serverless technologies and exploring them. And so they're things that maybe initially may not appear upfront, but again are what we hear over and over and over again when we talk to our customers. And so as we talk through some of the new features and capabilities today, I'll relate back to, again, some of these intangible aspects of things that just make your life easier and better when you're building serverless applications and infrastructure. Now, at the center of this world is a product that we have called AWS Lambda. AWS Lambda is a compute service that AWS first announced back in 2014, a little over 4 years ago. Since then, it has grown to be quite a large service with hundreds of thousands of customers, processes trillions of events per month, and continues to be one of the hottest services that we have here at AWS. So a bit of what I'm going to talk about here for a while now is now focused on AWS Lambda. Now, again, Lambda's been out for a little over 4 years now, and I put together this slide back in October for a presentation, and I think that it helps really kind of show just how sophisticated a product AWS Lambda is. And so going back to, again, our first preview announcement back in 2014, all the way up to just a couple weeks ago, we basically averaged a new feature capability per month for the last 4 years. And so Lambda is a very mature product here, again, with a lot of usage and a lot of customers doing interesting things. And we continue to evolve the platform and grow its capabilities pretty much almost every couple of weeks now. So it's important to follow and see the release history and the what's new that we have from Lambda. And again, going into just a couple of weeks ago, a bunch more things just got announced. Let's dive into some of those. So we talk about Lambda and we talk about this concept of serverless applications. There's essentially three main components to a serverless application. There's your event source, the thing that is basically going to trigger or invoke your Lambda functions. And these could be things like API-driven workloads from an API gateway. They could be storage services based off of storage technologies such as S3. They could also be things like our development and management tools, of which today almost all of them have support for invoking a Lambda function. And today we've got over 40 services at AWS that can directly invoke a Lambda function, plus the Lambda API, which you can encode into your own applications yourself. And then you have your Lambda function. So behind the scenes, the Lambda function is running on compute infrastructure. Essentially, we're maintaining those servers that exist behind the scenes in serverless. And so you could write your Lambda function in a number of languages. Previously, up until a couple of weeks ago, we supported Node.js, Python, Java, C#, and Go. And then at reInvent, we announced support for Ruby. And then as well as something called the Runtime API, which I'll talk about here in just a moment. But short story, it allows you to bring any language you want pretty much to Lambda. And so you write your code, you own that business logic, and then your application does whatever it needs to do. So maybe that's talking to databases or data stores or other web API endpoints, or really any service that you might connect to over a network. And again, that code and that logic is something that you completely own yourself today. Behind the scenes, we take care of the underlying infrastructure, scaling it, maintaining it, updating it, patching it, providing new runtime versions, and again, adding capabilities over time. When we talk about the anatomy of a Lambda function, there's a couple of core capabilities or concepts that you should know about. The first is the concept of a handler. Now, the handler function is what you configure the service to look for inside of your code to execute when an event comes in. And so the handler function is typically going to be the base point for any business logic that you might have and can route to, say, sub-functions inside of the same code base. But again, this is where you're going to tell the Lambda service, hey, this is the entry point for my business logic. Then there's the event object. This is what is passed in from an invoking source, such as either our API or one of those 40 other services that I mentioned before that can invoke Lambda, and it will contain the pertinent relevant information to what that event is trying to relate to you. So in the sense of an API-driven workload, this will be all the data from the API request. In the case of an S3-driven workload, it'll be information about the bucket and the object. In the case of, say, an SQS, simple queue service workload, this will be messages that were in the queue. And the event object will contain all the various bits of information that you would need for processing either that specific event or the data related to it so that you can complete your business action. And then lastly, the context object, which is something that is built into the platform that basically becomes methods available to your code base. Contains various bits of information such as the logging group, your timeout, the request ID, and these might be all pieces of information that you might want to interface with for various reasons. You might want to track or log or capture that somewhere. And so this is, again, information that is related to the request and the underlying platform that you can pull in. And now when we talk about a serverless function, again, you've got this code. You also very often have things like code dependencies, other libraries, and things like that that you might want to include. And so one of the things that we just announced a couple of weeks ago is a concept called Lambda Layers. This is a new capability inside of the AWS Lambda service. What layers allow you to do is to easily bundle and share code that can be across any number of functions. And this could be both shared publicly and privately as well. And so what we can do with this is, in a pretty straightforward way, take, say, certain libraries that we have. Maybe we've got things like monitoring or security libraries. Maybe we've got client SDKs from other services that we consume from a Lambda function. You can zip those up and upload them as a layer. And now layers are immutable. They can be versioned, and you have the ability to control which version exists at any point in time. They can be deleted or essentially deprecated by removing them. However, this doesn't break other functions that are consuming that layer. And a Lambda function has the ability to consume up to 5 of these. And so essentially, these 5 layers that you could have attached to your function, again, can include things like native dependencies, libraries from third parties, or really any other code that you want to have added to your function that maybe isn't directly related to your function's code. Essentially, at the end of the day, this is going to simplify and streamline the work required in having standardized libraries and in sharing code inside of your organization. And we think that layers are really going to help again, simplify and speed up the process in creating and expanding upon Lambda-based applications. And now layers are pretty cool. They also allowed us to build capabilities on top of them, such as the custom runtime support that we just announced as well a couple weeks ago. So this is powered by something called the Runtime API. And essentially what the Runtime API does is it brings to Lambda a new standard for being able to run custom runtime environments. Again, previously, AWS has managed all of the runtime environments, and with this addition of Ruby, we now have 6 different language runtimes that we manage for you. However, our customers have told us since the beginning of Lambda that they'd really like to have the ability to control the runtime themselves. Now, we don't want people to think that this is the default that they should use. In fact, you should continue to try to use the managed layers, the managed runtimes whenever you can. However, if you find that there's a language that we don't support yet as a managed language, or perhaps a version that you're looking for, or you're just looking to do something really unique and custom, the Runtime API can support that for you. So actually, the new Ruby support that we built is built on top of this Runtime API, and we'll continue to use it ourselves behind the scenes for our managed languages in the future. But one of the really great exciting things about custom runtimes is it supports the ability for you, again, to bring any runtime you want. So the way that the runtime works behind the scenes is that there is a concept of a Runtime Bootstrap. Essentially, the Runtime Bootstrap is what interfaces with the AWS Lambda Services Runtime API and is what allows you to run essentially any language that you'd want to inside of Lambda. And so it's pretty straightforward to use, and we've actually seen some really exciting uptake on this in the last week or so since we first announced this capability. At launch time, though, we worked with a number of partners to help launch some of the most popular languages that we've seen from our customers. From the AWS side, we've open sourced a C++ and Rust runtime, and you can find links to those off of the Compute blog, as well as in GitHub under AWS Labs' organization account. We've also then had a number of partners who were really excited about building other language support. So the folks at Alert Logic brought Erlang and Elixir, 2 languages that they're very passionate about. The folks at Blue Ridge bought COBOL, so you can actually begin to think about running your old school mainframe applications on Lambda. The awesome folks at AWS Lambda partner Stackery have created a PHP runtime. And the folks at NodeSource have brought their Node.js Enterprise solid layer to AWS as well. Since this is launched, I've also seen all sorts of other community-supported ones out there. I've seen Bash, I've seen other languages, and so I think we're going to continue to see some really awesome stuff happen in the space. And so again, you could use the managed languages from AWS, you can use the AWS open source languages, you can use partner-supported languages, you could use other shared open source languages, or again, you could very easily with the Runtime API bring and build your own runtime environment inside of Lambda. And so we think combined with layers, this is a really huge shift in how people are going to think about developing serverless applications. Again, we've now made it easier for you to bring and use any language that you want in the platform to be able to bundle and share common code components across your applications with layers. Again, with the same kind of event-driven serverless model that we've had since the launch of Lambda. Now, when you want to build all of these serverless applications that you're going to be building, you're going to want to use the tools that you've probably been using for a while. And so here at AWS, we have an IDE called Cloud9, which I'll show in a little bit here towards the end of the presentation. But what we've heard from a lot of our customers over the years is that they want to continue to use the tools that they have today. And so we also just announced a number of open source toolkits for various different third-party IDEs and development tools. So we have toolkits coming out now for PyCharm, for IntelliJ, and for VS Code. This joins some of the existing ones that we have for tools like Eclipse, for example. And so these are going to help make it, again, easier to consume and build serverless applications from these IDEs, debugging them, troubleshooting them, creating, deploying new ones. And so if you're using those tools, you can check out the toolkits that are available for each of them. And those that are just in developer preview, we're actively looking for feedback. We love to get that from you. And so please let us know, how you feel that we can improve those. So across Lambda, there are a number of use cases that we have. And really what we typically do is bucket them into the 6 most common Lambda use cases. The first is web applications. And so this would be replacing, say, a multi-tier web application stack with serverless, either driven by, say, Lambda and API Gateway, Lambda and AppSync, a number of different services that can help support the back end of, say, a static website or even a more complex website that you might be running. And so that's a massive use case for us here. We see lots of customers replacing old traditional, 3 and N-tier web application stacks with, say, things like reactive-based web interfaces and then API gateway and Lambda behind the scenes. In terms of backends, what we're referring to here is what we consider to be more typically microservice-based internal backends for applications. Now, this could also be supporting, say, mobile or IoT-based workloads, but we're seeing lots of companies as they move to a microservices architecture want to leverage Lambda and serverless applications in order to support that. Data processing, so whether we're talking about real-time, batch, streaming, or even MapReduce-based applications, is another one of the heaviest use cases that we see for Lambda and serverless technology. There are customers that are processing many thousands of Lambda executions concurrently at any point in time, doing things like processing, say, market trades, reading in, say, sensor data, reading in logging information. There's all sorts of stuff that we're seeing happen at a really high velocity with serverless. Chatbots, so this is another area of growth that we see with companies building new ways to interface with their customers, whether these be voice-based over, say, a phone line, or they actually be true chat-based inside of, say, a web browser, whether it be to support new or existing customers, or even organizations that are turning to chatbots for internal use cases. Say creating a chatbot that helps provide an interface to HR or facilities, for an example. Chatbots are becoming, kind of the new way that people think about in interfacing with, again, customers, internal folks, and stuff like that. Amazon Alexa. So if any of you have an Alexa-powered device at your home or at your office, many of the things that you ask Alexa to do are actually powered by Lambda behind the scenes. And so the Alexa team says that Lambda is the best place to build and run your Alexa skills. There's skills kits and SDKs today for Node.js and for Python. And so it's pretty straightforward and easy. It's actually a lot of fun to build an Alexa skill, and it's a great way to learn about Lambda and serverless as well. And then lastly, IT automation. This is probably where a number of you will first dip your toes into the serverless space. Lambda is really the world's best glue code execution engine. Whether we're talking about development tools, management tools, security tools, extending them with Lambda just makes sense. It fits a reactive or event-driven model. And so for a lot of these tools where you're, say, replying to a management event, or you're replying to, say, code being pushed down a code pipeline, or you're responding to, say, a security incident alert, Lambda can help, simplify and power all of the logic and policy engines that you have behind the scenes for those. So the serverless space is a lot bigger than just Lambda. One of the other big components that we have inside of serverless is Amazon API Gateway. And so Amazon API Gateway is an API management product that brings with it just a ton of capabilities. It's been out now for a little over 3.5 years, first announced in the summer of 2015. And API Gateway is used by customers with some really surprisingly massive scale. That are doing all sorts of different workloads, from consumer-based to internally based. There's quite a lot of interesting things going on in this space. And so what API Gateway allows you to do is, for example, create a unified API front end for all sorts of services, whether they be public or internal, that your applications might be consuming. It's got capabilities now like DDoS protection, WAF protection, multiple layers of security controls at both the client and backend side of things. You have the ability to plug in standardized and customized authorizers using products such as Cognito, or using Lambda functions to provide custom authorization behind the scenes. And then there's a number of developer-focused features such as throttling, metering, the ability for you to build effectively a monetization model on top of API Gateway. And so there's just a ton of things that you can do with API Gateway today. And we could have a whole webinar just on some of the more recent capabilities of that. And in fact, if you join us on December 13th, there is a webinar by my peer George Mao, who will be talking specifically just about API Gateway. So again, API Gateway, one of the coolest things about it is just how flexible it is. If we go and look at what API Gateway can do for you today, it can do edge-based APIs, which is basically APIs that are integrated with Amazon CloudFront. So for things like mobile and web applications, device-based workloads where those devices could be, or those clients could be anywhere around the world, you're going to want a CDN in front of that traffic. And so edge-based endpoints help you do that. We have another concept called region-based endpoints. This is for public services that typically only need to live inside of an AWS region. Or if you want to configure your own CDN or different CDN, this is another option for you as well. And then we also support completely private APIs that exist just inside of a VPC. And so this is for internal microservices, internal API workloads, whatever you might be doing with APIs that need to be private, it can be supported. Now, behind the API gateway, in terms of backends, we also have a lot of flexibility. API gateway can be powered by Lambda functions, by EC2, by ECS, Fargate, really anything across the compute spectrum here at AWS, as well as a number of other services. So there are a number of customers who will just put API gateway in front of services like DynamoDB, for example, and then present out a custom API to clients that represents that data. And then lastly, you can also back API gateway by both publicly and privately accessible endpoints that exist, say, completely out on the internet or privately inside of your own data center. And so again, with API gateway, it's one of the core components that we have here of the serverless stack. Now, at reInvent, again, just a couple weeks ago, we pre-announced an upcoming capability called API Gateway WebSocket support. WebSockets are a really hot technology trend that we've seen with customers looking to build much more, I would say, reactive and interactive application interfaces. So whether it be things like chat applications or interactive near real-time dashboards or IoT-based workloads, WebSockets as a technology is becoming increasingly important. And so we recognize that trend and have gotten a lot of customer feedback on this. Now, what's really cool about WebSocket support is that it's actually kind of a complicated technology paradigm. And so API Gateway handles all the hard bits for it. You can plug it back in front of almost all of the various technologies that I mentioned previously, such as Lambda, endpoints that might be on EC2 or ECS or Fargate, things like other AWS services, and then as well as publicly or privately backend endpoints. And so again, it manages the service for you. It manages the connection tracking. It continues to meet the standards of serverless, so you pay for what you use. It has high availability built in. And so this is coming real soon here, probably before the end of the year. And so keep your eyes open for this going into general availability. So let's talk a little bit more broadly about some other concepts in serverless here. Serverless is, again, in terms of Lambda, over 40 different services can invoke Lambda functions. And there are a couple that are maybe more common than others. So some of the most common architectures that we see, for example, is S3-driven workloads. So say an object is put into a bucket. That object could be an image file, an audio file, a video file, a document from, say, a customer. It could be a contract. Maybe it's a legal document. Maybe it's a medical file. Anything that might be uploaded from any sort of service goes into an S3 bucket. That can then invoke a Lambda function, which can then pull down that file. And then maybe it calls something like the comprehend service, or it calls transcribe, or it calls recognition, or it calls your own custom logic to look at that file, to parse that file, to pull data out of that file. And this is a really common model for this, again, event-driven programming model off of objects being put into S3 buckets. Amazon SNS, Simple Notification Service, is a service that often itself plays kind of a bridge between various different microservices inside of customer architectures. And so it's used really heavily as kind of what I would say is a kind of lightweight event bus between services. And so a message can go into an SNS topic, and then it can invoke your Lambda-based microservice on the other side. And so for service-to-service communication, or even in reaction to, say, things like management tools or developer tools, SNS is a common one. Amazon SQS, so back over this past summer, we announced directly integrated support for Amazon SQS and Lambda. And so today, the way this works is that messages go into a queue. The Lambda service runs a poller that polls your queue pretty regularly, which will then pull out those messages and send them into a Lambda function to be executed on. Now, SQS is a little fact here. The first AWS service we ever announced actually was launched before AWS was officially what we were calling ourselves here at Amazon in the cloud business, and it continues to be a very heavily used service by our customers. There's a lot of workloads where being able to queue up and batch messages makes a lot of sense, where you have asynchronous workloads that can deal with potentially a delay or backlog of messages. And so SQS continues to be a real solid workhorse in a lot of people's infrastructures. We also have Amazon Kinesis. So Amazon Kinesis is meant for near real-time, massive streaming of information from any source that you could think of back into your AWS infrastructure. The way this works is that data is written into what's called a Kinesis stream. That stream is then built up of shards. And then we, again, here on the Lambda side, run a puller. We pull those messages off of the Kinesis stream and invoke Lambda on your behalf. And we've got customers doing just massive throughput workloads with Kinesis streams, processing all sorts of information from, say, IoT sensor data, log information, market trade analysis, all sorts of things that we're seeing people do with Kinesis streams and Lambda. Amazon Lex. So Amazon Lex is a core component of both Amazon Alexa, but also something that you can use to build chatbots. And so when you build a chatbot with with Amazon Lex, there's a concept of fulfillment of the conversation. So if I tell my chatbot, I'd like to order a pizza, and it asks me some questions about what kind of pizza I want to order, at some point it needs to place that order for me. That is considered the fulfillment of the conversation. In this case, Lex can trigger Lambda functions to provide that fulfillment, as well as provide custom logic handling of my chatbot. And so it's really kind of the thing that helps add that dynamicness to the capabilities of my chatbot. And then lastly, a really straightforward, simple example of a serverless architecture. I myself am a former operations or DevOps person, as it were. I've run lots of cron-based scheduled jobs and workloads and stuff like that. And you can actually replace all of those that might be running on a physical or virtual server somewhere with a combination of CloudWatch scheduled events and Lambda. And so this allows you to have the ability to schedule Lambda functions execution down to, I believe, the second level. And so there's a lot of things you can do with this in, again, replacing traditional cron-based workloads. Now, sticking with Kinesis here for a second, right before reInvent, we actually announced support in Lambda for the new enhanced fan-out capabilities of Kinesis data streams, as well as support for their HTTP to API. Both of these allow you to basically pull data out of Kinesis in a faster as well as in a higher volume rate. And so it's very common that data that goes into Kinesis needs to be consumed by, say, multiple different Lambda function-based applications, as well as often you will have so much data going in that being able to pull it out rapidly becomes really critical. And so both of these features together enable that for you and will allow you to, again, consume Kinesis data at a greater scale and at a faster rate. So the next thing I'll talk about here is kind of stepping up in the orchestration viewpoint of how you think about serverless applications. And so one kind of really boilerplate best practice that we have here for serverless applications is that you should keep your orchestration out of your code. Now, what exactly does this mean? It's really common for you to have inside of application code, say, a call to an external service like an API. And maybe when you call that API, occasionally things break and they fail. Whether it be something that you're managing or something that someone else is managing. And so, as a good developer, you put in failure code, you put in things like exponential backoff and retry code, you put in all sorts of various sorts of, essentially try and catch failure logic. And this can actually become more of your code base than your actual business logic. And so with this, we have a service here at AWS called AWS Step Functions. What Step Functions allows you to do is take all of that workflow logic, all of that workflow code, and extract it up to a higher level. And so Step Functions provides workflow management on top of Lambda, and as well as some other things we'll talk about here in a moment. Now, some of the capabilities it provides is stuff like exponential backoff and retry handling logic for you, as well as things like decision tree capabilities, parallelization, all sorts of things that basically help, again, remove the need for you to have to put that type of workflow management inside of your code. And now it's been able to invoke Lambda functions since it first launched. It's got really deep integration with Lambda, can handle custom Lambda logging messages. But what we've heard from customers is that they want it to do even more. And so, again, just here at reInvent, we announced integration with a number of other services here at AWS, including Amazon Simple Notification Service, SNS, Simple Queue Service, SQS, SageMaker, which is in our machine learning space, AWS Glue, which is an ETL and data transformation service, AWS Batch, which can allow you to handle batch processing of data and messages, the Amazon Elastic Container Service, ECS, as well as AWS Fargate, which is serverless containers. And so now what you can basically do is invoke and integrate with all of these different capabilities beyond just Lambda. And so just as a quick example of this, if we were using Lambda functions and I needed to process, say, a batch job, I can have Lambda kick it off, basically wait and poll and look for the job to finish. If the job completes, process the status of it, and then send on a message to SNS. Now with step functions and these new integrations, it's as simple as have my step functions kick off a batch job, and then based on the response, either invoke a success or failure message to SNS. Wow. This is a massive change and a massive shift in terms of what developers had to do previously. We think this is going to really, really simplify and reduce the number of Lambda functions that people had in some of these more complicated workflows. And so we're really excited about this. Personally, I think it's going to be, again, really transformative, just like Layers, just like the Runtime API, just like WebSockets. So we've talked about a number of the services and the platform and their capabilities. Let's talk about some of the tooling that exists to allow you to manage these things. And so here in the serverless space at AWS, we have a little friend of ours we call SAM. And you see the squirrel mascot for SAM right here. So this is Sam the squirrel. So SAM, or AWS Serverless Application Models, is a template-driven tool for helping to manage your serverless applications. Now today, this is an extension built on top of CloudFormation. CloudFormation is one of the core development and management tools here at AWS, used by customers of all different shapes and sizes. Now what SAM does is it drastically simplifies the work involved in managing serverless applications using CloudFormation. And so what it brings with it is a number of custom resource types. Now, when we first launched SAM, we had functions, APIs, and simple tables. But we recently just announced layers and something called applications, which we'll talk about here a little bit more in a moment. And so layers support is obviously for the Lambda layers. And so now you can really easily with SAM manage those. Now, you can also manage almost anything you could think of with CloudFormation inside of SAM. So we support almost all the resources that CloudFormation supports today. Now, this is an open specification for the template, but also what's called the translation layer for SAM. And so we've seen a lot of awesome community involvement in helping us expand SAM and its capabilities. It's also gained a lot of new capabilities over the last couple of months that is a little bit more fine-grained than what we've going to hear in this conversation today, such as the ability to support custom authorizers for API gateway endpoints, and all sorts of other capabilities to help you simplify the building and developing of your applications. So this is an example SAM template, and we'll break down what's going on here with really kind of three components. The first is we have at the top here our CloudFormation headers. And so we see the AWS template format version, but then we see the second line here called transform. Now this is maybe the most important or unique aspect about a SAM template. And what this does is it tells CloudFormation that, hey, there's going to be some special resources in here. You're going to need to transform them into traditional CloudFormation resources. So you always have to include the transform line. Then we have two different resources inside of this. We have a getHTML function and a list table. Now the list table is pretty straightforward. It's actually just an AWS serverless simple table resource, which corresponds to an Amazon DynamoDB table with 5 read and write units today. But if we look at the getHTML function, there's some slightly more interesting things that are going on here. We see properties from both a Lambda function, such as the code URI, the handler, the runtime, and then policies, as well as properties related to an API endpoint. And so we see here the event structure called getHTML, it's type API. We then have properties of /proxy plus support, and then the method of any. And so what's going to come out of executing this SAM template is a Lambda function, an API gateway, a DynamoDB table, and then all of the glue necessary in, say, IAM policies to make these things be able to interface with each other, as well as then deploying my code up to my Lambda function. Another way to think about it, and this is from a public sample that we have up in GitHub, is that from lines 10 to 25, essentially 15 lines of code, we're actually configuring the capabilities for 7 different AWS resources behind the scenes. So again, SAM is really going to help you simplify what you're doing in building and deploying serverless applications. If we were to do this in just raw CloudFormation, it would be sometimes 4 or 5x as much code to get the same resource definitions put in. So SAM makes essentially best guess efforts at gluing together various capabilities for you. It's got a number of what I would consider to be very sane, best practice-driven defaults built into it. And so again, it can really help you in building your serverless applications. Now, another thing that SAM does is enable another product that we have here in our serverless portfolio called the Serverless Application Repository. And so the Serverless Application Repository, which you could find either via the Lambda Launch Function console or publicly we have the Serverless Application Repository available, is a collection of either public or private applications that are completely serverless that are bundled together. So as a developer, there's a lot of cool things that you can do with the Serverless Application Repository. So again, you can discover pre-made applications that have been shared publicly by others, as well as publish your own, as well as publish or consume privately made applications that are shared, say just inside of your organization. Now, just back at reInvent, again, a couple weeks ago, we announced a new capability based off of this called nested applications. What nested applications allows you to do is to combine one or more pre-existing applications in the app repo with your own. An example here is that we see a function called Lambda Authorizer Basic Auth. This was actually provided by Dougal, who is the lead PM for API Gateway today. And what it is basically, as it sounds, an example of doing basic HTTP auth inside of a Lambda function. And so what I could do is create then a serverless API-based workload where I nest inside of my app this authorizer and say that this authorizer is what I want to use for auth in my application. Now, I don't have to then go and download the code that Dougal wrote. I don't have to manually go and launch this application that he's had and then find the various resources created, glue that into my own template. Instead, what I can do is relate basically this application to my own using SAM. And then when I launch my SAM template, it will take his application, launch it as a nested application inside of mine, and allow me to more easily relate to the resources inside of this. And so, again, this is really going to simplify the code that we see companies writing. This is going to reduce the amount of applications, bits and pieces that you have to write and think about yourself. When it comes to both public and private reuse, it's just going to simplify that even further. So let's dive into now what has changed inside of SAM Templates capabilities, given these new feature and capability launches that we have. So serverless function, again, gives you the ability to define a Lambda-based function as well as relate it to its event source, so its invocation source today. We support almost all the capabilities and various attributes of Lambda inside of this. You see some examples here. There's actually more than I could easily fit into this little code window. And we also then again recently announced the support for layers inside of Lambda functions. With serverless APIs, you can define a number of the capabilities for APIs now, including things like auth and CORS support. Simple table, we've got a whole bunch of the various things that you'd want to configure for a DynamoDB table. And then the two new capabilities that we have here in SAM are layer version. And so pretty straightforward. This allows you to define a layer that can then be consumed by other serverless applications inside of your infrastructure. And then lastly, serverless application. So this allows you to define an application that will become nested inside of your own. And so we see here that there is an application ID, which is an ARN to a function that exists in the app repo. It has a version. I can configure its parameters. And then later on, I can consume the resources created by this nested stack. Now, going along with the capabilities of the template is the AWS SAM CLI. The SAM CLI is a tool that allows you to do all sorts of things local on, say, your workstation or wherever it is that you do development of applications. And so SAM CLI has, again, a number of capabilities. We can do everything from create a brand new Lambda-based application to doing local debug and testing, to then being able to package and deploy our serverless application, as well as being able to then tail the logs of that application once it's running up in our production environment on actually AWS Lambda running up in the cloud. Now, brand new capability that just was announced just about a couple weeks ago here is a capability inside of SAM to allow you to build in native dependencies. And so the SAM build subcommand will actually go and look for the dependency files such as requirements.txt that might exist inside of, say, a Python-based application. And then we'll actually go and pull in those dependencies, put them in the right place inside of your application repository, And again, just simplifies that much more of the process that you would need to do. Now today you can run SAM on Linux, Windows, and Mac. We also see people running it inside of things such as Cloud9. And so Cloud9 is AWS's managed cloud-based IDE, has all sorts of capabilities and deeper integrations with AWS and various services and resources that you would interface with. So in this screenshot here, we see in kind of the center pane that we have here, I have a JavaScript-based Lambda function. And then over on the far right-hand side, you see actually the built-in Lambda function debugger and tester that comes inside of this. It's actually built on top of SAM. And so we see that I'm passing in an empty payload. We see the results of that empty payload, or essentially the response. We see function logs and things like that. And so I feel personally that Cloud9 is a great place to go and build serverless applications. And so with that, let me show you a quick demo of using the SAM CLI up on Cloud9 and what we can do to get started here. So what I have here is a up and running Cloud9 environment, and I launched this just before this webinar here. So it's got really nothing too exciting going on with it. And so inside of Cloud9, which runs on top of an EC2 instance, I could do things like have terminal windows. I've got text editor windows, all sorts of things that I can do as part of it. Let me actually collapse down that and open up a new terminal window over here. And so I've got SAM pre-built on this environment already. I have it updated here to the latest version, which as of this webinar is 0.8.1. And so again, if we look at SAM and what's possible inside of it, we've got a number of capabilities. And so we see down here in the command section all the various options that exist for SAM. Again, I can use it to tail logs from a production running application. I can deploy a SAM application that's been packaged. I have to package it before I can deploy it. I can use SAM to do that. I can initialize a new serverless application. I can build its dependencies. I can validate my SAM template. And then I can execute SAM local. And so one thing I haven't mentioned yet is that with SAM, what we do is we take your application and we can bundle it into a locally running Docker container and then mock either an API gateway interface or a Lambda API interface. And so this would allow me to test both HTTP API-driven clients as well as invokes for, again, any other AWS service that I might want to test against. And so in this environment today, I've got really nothing going on, but let's go ahead and start building an application. And so with SAM in it here, I have the ability to create a new application. I could specify either a path that exists up in GitHub. I could specify a path that exists out on some sort of HTTP repo or location where it might be. In this case, though, SAM will also allow me to create an application just directly based out of stuff that it has built into it. So let me go ahead and create a Python application. I'm going to make this with Python 2.7, which is a little bit older, but it's something I'm familiar with. And so I just typed in SAM init-r python.27. And now over on the left-hand side here, I have a directory structure that contains all of the various bits that I need for a very basic pre-built default application. And I can come here and look at the README file, which is going to go and explain, again, what the application structure looks like from a directory standpoint, setup process, and what I need to do to help get this application up and running. Now, this application has a SAM template pre-existing inside of it. So I can go and look at that SAM template. It's a pretty straightforward SAM template. It has a single Lambda function defined, or serverless function, I should say. It's got some basic capabilities about my function. And then it's got a pretty straightforward event structure. And so the path to test this function is /hello. Now, it also has in here a requirements.txt file. This contains just a single dependency that this application is based upon. And then my application code, which in this case has a whole bunch of stuff commented out to give you some information about what's going on here. But the meat of this is really straightforward. It's going to make a request to the check IP URL here, which should just return my IP address. And it's then going to take that and add on the message hello world and respond back to that. Great. So what can I do from here? Well, I want to get this application up and running. So let me actually go in and get my dependencies. And so I come into the root of this directory and I execute SAM builds. Okay, Okay, so I've just executed the SAM build command, and as you can see now here on the left-hand side is that it's created a new directory structure for me. Under the .aws-sam directory, I now have a build directory, and then my hello world function directory, which contains all of the requirements that were brought in. Now, my requirements.txt only had the requests requirement, but SAM build went and pulled in, using the package manager for Python, all of these other dependencies for me. And so I've now got basically everything that I need to have to execute and run this function. Now, I could use the built-in debugger that I have here in Cloud9. And if I go over to the right here to AWS Resources, find my application, I see the Lambda function here defined. I can then go down to run and say run local, both for Lambda and for API Gateway. But instead, let me just do this natively inside of the console window to show you what the experience would be like if you're doing this outside of Cloud9. So I need to go into the AWS, the .aws-sam subdirectory, and then into the build directory. And inside of here is my template file again, packaged up into this directory. So let me go ahead and execute SAM local, start-API, and reference that file. Okay. Now you notice at the very bottom here that it tells me that my service is now running on localhost port 3000. And so if I now go and open up a different terminal window, I can curl this /hello, because hello is what was defined in my template file as the path for my API. Let's go ahead and execute this. Great. And so I got back here a response for my application. Now, one thing that you didn't see here, due to some editing magic, is that I actually went and edited this application code briefly to say hello tech talk. Let's actually change this here to make it say, see you soon. So I've gone and just edited the app code. Now I'm going to go back and make a request again to this endpoint. And now we see that my message has changed to see you soon. And so again, what I'm able to do here and what I've done very quickly is I have defined my application. I have then, I created a brand new application from scratch that came with a SAM template, my application code, requirements.txt, also came with a test directory for unit tests. I then use SAM build to pull in the dependencies that I need. I then use SAM to fire up my application locally. And I can actually come back to this other window here and see the output logs from this function and see kind of the same kind of content that I would see from the Lambda service if it was running up in Lambda. And I'm able to then throw basically, mock invocations or mock API requests at this Lambda function itself. Again, all of this just using the SAM CLI and being able to, do real-time development of Lambda, changing my code, testing it, and so forth. So again, SAM CLI, super powerful to get started with, and a great way to explore the serverless space. Okay. So wrapping up here today, we've talked about quite a lot of various different things and stuff that's just been launched here with the serverless space at AWS. In terms of Lambda, we've got things like Lambda Layers and the Runtime API, which are just going to, again, broaden the languages that you can run inside of Lambda, as well as help simplify the ways that you think about packaging both shared code and dependencies, and really any code that needs to exist across Lambda functions. Talked a little bit about some of the additional capabilities around new support for Kinesis streams as fan out and HTTP2V API. Talked briefly about the upcoming WebSockets support and API Gateway. Talked about all the new capabilities and step functions. I think they're really exciting. They're going to really reduce code even further. And then very quickly had a rundown of how you can test and debug your serverless applications using both SAM templating system to define them, and then the SAM CLI to actually locally test, debug, and build those applications. Now, almost everything that I've talked about here today, you can find at our serverless landing page at aws.amazon.com/serverless. From both links to webinars like this one today, as well as things like our Twitch series, blog posts, getting started guides, customer case studies, reference architectures, all sorts of resources. You also see here a link to the AWS Serverless Application Repository, links to the developer tools ecosystem that exists in the space, as well as partners that we have that can help you build serverless applications and that build technologies to help you manage your serverless applications. My name is Chris Munns. You can find me at munns@amazon.com or at Chris Munns on Twitter. Would love your feedback. Would love to be able to help you out if you ever get stuck or run into issues. So feel free to reach out to me via either of these means. We want to thank you again for joining us here today in our Tech Talk, and hope we see you soon. We're going to attempt to handle some questions here. And again, thank you for coming.